Hello, I am Joshua Gold for Mr. Ferraria's first period AP Calculus BC class, and we will be doing number 13 through 16 on the review for our final in a few days. Since my writing in Microsoft Paint sucks so much, I guess I'll be doing it on a whiteboard. For your convenience, of course. Okay, number 13. Alexis, who is 5.7 feet tall, walks at a rate of 5 feet per second towards a streetlight that is 20 feet above the ground. At what rate is the length of her shadow changing when she is 10 feet from the base of the light? Round t to the nearest 0.5 feet per second if necessary. Okay, so what we should do here is, well, so we know that Alexis is 5.7 feet tall, and we know that the stoplight is 20 feet tall. Alexis is 10 feet away from the stoplight, as shown. So I'm going to write 10 here. And we are looking to find the rate at which her shadow is changing from the light. So that would be an extension out here as the light shines down on her and projects the shadow outward. Okay. As you can see here and here, what looks like is that we have two proportionate triangles. We have the first triangle, the overarching triangle, which has a height of 20 and a base of what I'm going to call x plus y. And I'm going to set 10 equal to x, and this extra length of Alexis's shadow equal to y. And we have another proportionate triangle with a height of 5.7, i.e. Alexis, and a length of y. So I'm going to create a proportion between the two. So 20 over x plus y equals 5.7 over y. So I'm going to cross multiply 20y equals 5.7 x plus 5.7 y. And now we're going to solve for y. I'm going to subtract 5.7 over and get 14.3 y equals 5.7 x. Next, we are going to divide this over. Y equals 5.7 over 14.3 x. Okay, I'm going to go ahead and erase the most of this. Hopefully you've got that all down, since I have very limited space. So we know that y is equal to 14.3 over 5.7 x. Oops, sorry about that. other way around. Y equals to 5.7 over 14.3 x. Okay. So, now that we have this, we can now know the total length in respect to x of the entire triangle. How we know this is, since we have y here, we know what y is equal to in proportion to x. We're going to call the entire length L, and because this is and I'm going to plug in y for 5.7x over 14.3 plus x. 5.7x over 14.3 plus x adds up to 20 over 14.3 x. Okay, now we're going to solve. Now we're going to solve for dl dt as we're looking for the change in length of the shadow. dl with respect to time equals 5.7 over, I'm sorry about that, 20 over 14.3 dx dt. Okay. Now, what we know about solving for x is that if you multiply, if you do the reciprocal of this equation right here, on the reciprocal and multiply it onto y, you'll have x equal to 14.3 over 5.7 y. And now with this equation, we also have the equation of the length in terms of L. L equals y plus 14.3 over 5.7 y. Now, we're proportionate in terms of y in this equation. And this is going to equal 20 over 5.7 y. And if we solve for in respect to time, this becomes dl dt equals 20 over 5.7 dy dt. Now, if you can see, we have two different equations in respect to time that are equal to each other. I'm going to make some more space. I'm going to set these equal to each other. 20 over 5.7 dy dt is equal to 20 over 14.3 dx dt. Now, if you look back to your problem, it is given that Alexis is walking towards the light at a rate of 5 feet per second. So, the distance between Alexis and the light is, as I've given, the value of x. And so, the distance in respect to time would be 5, is given right here. So, erase this, multiply by 5, we get 20 over 5.7 dy dt equals 100 over 14.3. Now we can cross multiply to solve for dy dt. Cross multiply, and we'll get 570 over 286 is equal to dy dt. Oh, something I forgot to add is because Alexis is decreasing distance at a rate of 5 feet per second, 5 would actually be negative. So this entire equation would be negative, and ultimately our distance, y, would be shrinking as she's going over, moving towards that light. And so this equation would be negative. And this is your equation. And this comes out to the answer of about negative 1.993 feet per second. And this, ladies and gentlemen, is about your answer. Okay? Got that all down? Okay, good. Moving on. This looks like this doesn't want to come off. Well, that's very unfortunate. I'm just gonna do this for now. So, one second. So, moving on. Number 14. Number 14. As a balloon in the shape of a sphere is being blown up, the volume is increasing at a rate of 4 inches cubed per second. At what rate is the radius increasing when the radius is equal to 1 inch? Okay, so we're looking at a balloon. Balloon's expanding. We've got a sphere. Greatest sphere you've ever seen, I know. And we know that the radius is 1 inch. I'm sure that's very legible, but that is 1 inch drawn to the best of my ability. And now we know that the volume of a sphere is 4/3 pi r squared. Sorry, pi r cubed. Oh, wrong side. Pi r cubed. So, since we're looking for how much that the volume is increasing in respect to time, we need to take the derivative with respect to time. So that would be dv dt, which is equal to 4 pi r squared. Now, a little tip, a little hint, a little tiny aside right here. This is actually the surface area of the sphere. A little cool thing you see there. You take the derivative of the volume and it's actually the surface area. Cool little aside. Anyways, so we're given that the volume is increasing at a rate of 4 inches per second. Now that, ladies and gentlemen, is the volume with respect to time. We have that right here as dv dt. So that I'm going to replace with 4 inches as it is given, which is equal to 4 pi, oh, little thing I forgot here. Then when you take the derivative, you need to put it in respect to, we're looking for it in respect to r, as it is it is not constant and it is changing. So that is equal to 4 is equal to 4 pi r squared dr dt. And now we're going to plug in the given radius, 1 inch. It's going to give us 4 equals 4 pi 1 squared dr dt. Okay, that 1 squared, you know, that completely doesn't matter because 1 squared is just 1. So we need to solve for dr dt. So what I'm going to do is I'm going to divide over the 4 pi onto the 4. Go up here. And that's going to give us 1 over pi is equal to dr dt. Simple as that. That's our answer. Inches per second. Don't forget that inches per second. Never forget the units. I've forgotten that way too many times. That's why my grades are in the trash. Anyways, moving on to number 15. And I've ruined this board. It's okay. It's worth the extra credit. Number 15. Okay, and that's on another piece of paper. Number 15. Find the area of the region bound by y equals to x cubed minus 6x squared plus 8x and y equal to 0. Okay, so we'll write down y equals to x cubed minus 6 4x squared plus 8x. We put over here that y is equal to 0. Now, what I am going to do first is I want to find out what those zeros are, because that's going to give us the integral. That's going to give us the basis for what we need for the integral later on. So we'll plug in that y. 0 equals to x cubed minus 6x squared plus 8x. Now we're going to solve that. Find those zeros. So negative b, so that's going to be positive 6 plus or minus square root of blah 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 blah. You know what I'm getting at. And ultimately, all of that is going to get you zeros at 4, at x equal to 4 and x equal to 2. Okay, so this gives you the integral of where it goes. These give you the zeros, and this is the basis of what our integral is going to be based around. So I'm going to take the integral because we're trying to find the area of the region. The integral. We're going to start from 0 to 2 of x cubed minus 6x squared plus 8x dx. That is going to be plus the integral from 2 to 4. As you see, another part of the other 0, of the same equation. Hopefully, I guess I can't fit it on here, but you get the gist, where that the dx is also there. Okay, so now we're going to take the integral. We're going to take the antiderivative, and that's going to be 1/4 x to the 4th minus 2x to the 3rd plus 4x squared. Now, I'm going to do a little thing that we haven't really done, but you'll see where I'm going at. So I'm going to be doing this from 0 to 2, and also, since it's the same equation, from 2 to 4. Now, I'm sorry if this confuses you, but I'll explain. Basically, I'm just saying that this equation, we're going to be doing this, we're going to be plugging in 0 and 2 into this, and then after that, we'll add on plugging in 2 and 4 into this equation. It saves room, you know, you get what you get it. I don't have a lot of space here. I'll do what I can. Okay, so let's plug in. So if we plug in 0, then since there's x's in all the parts of this equation, if you plug in 0, it's just going to be 0. We don't have to care about that. But since 0 is the first part and 2 is the second part, once we plug in 2, the entire equation has to be negative, because if we plug in 0, then it would be 0 plugged into this equation minus 2 plugged into this equation. So we put negative right there, a little bitty negative, and let's plug 2 minus 2 times 2 cubed plus 4 times Okay, now, if you're following along, you'll see that in the next equation, there's a 2. Now, what I figured out about this is that we can actually multiply this entire equation by 2, and that will take care of that part right there. Now to plug in 4, so I'm going to subtract it because the 2 takes care of the first part of the integral. Now we need to subtract the second part of the integral. So plug in 1/4 times 4 to the 4th minus, oh good, ran out of room, 2 times 4 cubed plus 4 times 4 squared. Okay. Now this first equation is going to come out to 8, if you solve that out. And then your second equation, oh wait, hold on. There's actually no negative there. My mistake. Anyways, I may have just screwed this whole thing, but it's okay. Anyways, this is going to solve out to 8. This, in fact, is actually going to solve out to 0, weirdly. And so, if 8 minus 0, which equals 8, and 8 is in fact your area, and the answer. Anyways, moving on to our final problem of the night. Damn, it is late. Okay, number 16. Number 16. Find the area of the region bounded by the graphs of x equals y squared plus 4y and x equal to 0. Okay, so we're given that x is equal to y squared plus 4y, and we're given that x is equal to 0. Okay, just like the last problem, I want to solve for the zeros first. Find the zeros of this equation so we can put them in the integral. So 0 equals y squared plus 4y. Now your zeros in this equation are going to come out to y equal to 0 and y equal to -4. Okay, next we're going to take the integral as we were finding the area. The integral, and the integral is going to be from those zeros. 0, or rather -4 to 0 of y squared plus 4y. Okay. Next. Okay. So now we're going to there we go. Next, we are going to take the antiderivative of the equation. That's going to give us 1/3 y cubed plus 2y squared from -4 to 0. Okay. And so, if you plug in 0 into the equation, if you plug in -4 into the equation, we're going to plug in -4 into the equation. And then that would be subtracted by 0, but if we plug in 0, then it would actually be 0, so that's not going to matter. This comes out to -64 over 3 plus 32. And that is going to give us around 32 over 3, which is in fact our answer. And there you have it, ladies and gentlemen. These 4 miserable problems done by someone who does not know how to make these kinds of videos. Okay? Good luck on your tests.